History rewards the innovator, the pioneer, the trailblazer. For over 30 years, Supermicro has been fueling innovators and visionaries with the industry's best computing resources. We have built the industry's widest portfolio of storage servers with the largest open ecosystem of leading storage hardware so that you can be first. Welcome to Supermicro's 2025 Open Storage Summit.
Hello and welcome everyone to the Supermicro Open Storage Summit, where we're going to explore storage for agentic AI solutions. I'm Rob Strechay, Managing Director and Principal Analyst. We're entering a pivotal moment in enterprise AI as organizations embrace agentic AI, AI systems that can make autonomous decisions, perform multi-step tasks, and interact in complex ways. The infrastructure behind these capabilities is being pushed to its limits. This isn't just another evolution of traditional AI workloads. Agentic AI introduces a new class of challenges, especially when it comes to the storage infrastructure. These systems demand massive high-speed, low-latency storage paired with scalable, flexible architectures that can seamlessly manage diverse data types integrated with compute and networking layers and still meet strict performance, security, data governance, and cost efficiency requirements. At the heart of agentic AI are intelligent frameworks built around large language models or generative AI models, the brains of the operation. However, surrounding that brain is a sophisticated support system that makes autonomy possible. Take the key value cache, for example. It acts as a short-term memory, storing immediate results and memory tokens. This enables the AI to retain context, move faster, and remain coherent across extended conversations or complex workflows without reprocessing everything from scratch every time. Then there's the control flow layer, which orchestrates how agent plans, retrieves information, and executes tasks. In many enterprise scenarios, that means tapping into retrieval augmented generation, or RAG, integrating tools like vector, database, and knowledge graphs to make reasoning more semantic, causal, and adaptive to new inputs. Another powerful feature is tool invocation, where AI agents call external APIs or internal services to get things done in real time. These systems also feed on feedback loops, continuously improving their decision-making based on real-world outcomes and business goals. When you combine all of this with capabilities like model hosting, vectorization services for unstructured data, and agent catalogs for managing reusable modules, you start to see foundation for truly scalable multi-agent ecosystems, systems that can reason, act, adapt, and importantly, explain their choices. Really important. Today's session brings together experts to unpack what it takes to build the resilient storage infrastructure that can power these agentic AI systems at scale. From technical considerations to practical recommendations, we've got it for you here. So let's dive in. First off, we got Kevin Kang from AMD. Thanks for joining us. Praveen Midha from SanDisk. Thanks for coming on board. Balanjay Venkateshwara from DDN. And Vince Chen from Supermicro. Really appreciate you guys coming on board. I think that this series, the Supermicro Open Storage Summit series, and really diving into agentic AI, probably one of the hottest topics going this year. I first want to kind of take a step back and get each of your company's perspective on agentic AI and storage for agentic AI in specific. And Kevin, let's jump into it with you first.
My name is Kevin. I work for the AMD and manage the embedded storage segment. So I'm really happy to here, to talk with everybody and to share, our vision and our view of how AI shaping the data and shaping the storage today and what's the requirement change. And the other thing is I want to share with how AMD to build the whole infrastructure to support this new AI era. The first question is why storage is important to AI today. So since we're moving to the agentic AI, so not just the AI giving answers, AI today learn by itself and adapt and take the actions after that. So the system needs to be access data fast, use it well, and update data in the real time. So to understand that, let's take a look at the data flows in the AI path. So there are 3 key stages in AI data path. The very first one is called data lake. It's loading the data to the training systems. For example, like the documents, photos, videos. And those are sequential data. It's required fast loading, and the high bandwidth for the storage is the key. And the other layer, we're talking about preparing the data for the trainings. So in this phase, so data need to be cleaned, labeled, cached, and transformed. Most of the activities in the memories. So this requires fast I/O and good memory bandwidth and need CPU orchestration to manage multitasks. If this stage is slow, so the whole training process becomes expensive and delayed. So the third thing is about inference. So this is where the agentic AI is. So AIs keep reading new inputs and make decisions fast. So for example, like what we use today, chatbot. They provide the real-time answers and need the real-time response. And we don't want to wait. And the other thing is the car detecting the surroundings objects. We don't want to wait too. So this required very, very low latencies and a lot of memory traffic. So need memory access directly to the GPUs, and we don't need to wait CPU response. So how AMD can help here? So we start from EPYC CPUs. So our CPUs support large amount PCIe lanes, high core counts, and strong memory controls. It's really perfect for pre-processing the data and managing storage I/O and supporting NVMe or high-speed networking. So we also support longevities and the reliabilities to the storage solutions. So the second things we're talking about GPU families. So our newest GPU are made for both trainings and the inference. So they support direct data paths and from storage to GPU memories. That means data can move faster with less delay and use less CPU resources. And beyond that, we have SmartNICs and DPUs, and those special chips that helps move data secure during data transfer, and also offload storage tasks, make the larger system run smoother, especially in AI clusters. So beyond that, we also have the edge, we have the client portfolio to support AI infrastructure. But we not only have the hardware, so we also have the ROCm in the software stack and connect everything together. So make the developers can easily leverage the AMD best hardware portfolio to support AI infrastructure. So now let's take a second look at the first slides. So AMD is well positioned in all the stages of the AI storage, but we're not doing this alone. So today here, we're with our partners, and we build tested, optimized, and scalable solutions from edge to cloud, from research to the real-world deployment. So in summary, agentic AI is not just about smart models, it's about fast, intelligent infrastructure that support them. Whether you're training large models or running real-time inference, AMD work with our partners and to help you move data faster, make a decision faster. Thank you so much.
Great. I think let's move a little bit down the stack here. And Praveen, why don't you kind of take us into what SanDisk's proposal or vision is around agentic AI?
So thanks, Rob, and thanks, Kevin, for that great introduction. Thank you, Rob, for setting the whole conversation up. I think it's important to really understand why agentic AI is important and how it's evolving as we look ahead. So I have really 3 slides, but I think I'm going to spend the bulk of my time on the first slide because it's important to set the context. What is agentic AI? Agentic AI is called agentic AI because it has agency. Agentic AI systems can act autonomously, they can make decisions, and they can complete tasks without with minimal human intervention. Agentic AI can think, they can reason, they can act independently, they can plan. And if you really double click what agentic AI is doing, it's really leveraging a use case as an inference workload, where it's able to make these decisions based on prior training sets. I think it's important to realize that inference has really evolved over the years from perception, which was really labeling, analyzing images, to generative AI, which was just giving single shot responses, to now where we are with complex reasoning with agentic AI, and then moving on to physical AI and robotics. What we are seeing is this trajectory of complexity going literally 100x as we go from one shot, single shot response to multi-step response with inference. So the messaging that we are hearing, and I think you hit it on the head, is that 2025 is really the year of inferencing and agentic AI, because we were actually severely undercalling the amount of compute and storage that inference and agentic AI was going to translate into. Now, if you double click under the hood, what we see is that inference is really a two-stage process. There is a prefill and there's a decode. Prefill is really where you take the input tokens, you start building up the context in this intermediate buffer called the KV cache, and then on the decode side, you actually start outputting tokens, and then you also take these tokens and build it back into the KV cache to really hold all the context as you are. So in a way, it's auto-regressive, right? Why is all that important? Well, it's important because what we are realizing is that as we go to more complex use cases like multi-turn, multi-step, multi-users, multi-tenants, multi-modal, the complexity of these KV caches in the case of hyperscalers, as well as like you talked about on the enterprise side with RAG use case where you're vectorizing data, you're seeing a huge multiplication of these data sets that are harder and harder to hold in HBM or system memory. And what we are also realizing is that it's probably a lot faster to swap these KV caches and data lakes or vector lakes in and out of storage than to rebuild them from the get-go every time the user comes back or you have to restart token generation. So bottom line, the story is storage is a critical enabler for agentic AI. We need it because we can get to the first token, what is called time to first token, reduce latency, and really cut down on unnecessary GPU computation by reestablishing the KV cache every time we have to start again. So that's probably the high-level overview. I think also important to realize is that as more and more enterprises are moving towards agentic AI inference workloads, they are actually taking a lot of the cold data and moving it into these larger data lakes, which really means that the data temperatures inside the data center are going up. And you're moving from traditional HDD-based data lakes, archives, to flash-based data lakes. So that's really the point we are making in the first slide. On the second slide, I think we are trying to make an important point that there are really two sets of SSD requirements that we are looking at. One is on the left side is the compute intensive or the performance intensive SSDs, and on the right hand side is the focus is more on capacity density. Both are important, and we have two swim lanes that address both of these swim lanes. The compute intensity is all about random reads, high IOPS, as well as sequential writes. And then the focus on the right hand side is mostly around sequential workloads, because that's where you are doing swap in, swap out of these KV caches or vector lakes, or in the case of training, you're doing snapshots. So we have a very strong portfolio both on the compute side, which is on the left side, which is adjacent to the GPU, and in the data lakes that are really connected over the network into the storage side. And I'm sure Balaji will cover a lot about the storage piece as we go along.
Yeah, I mean, I think for that, let's jump into it. Balaji, I think, again, that you really, when you look at it, I mean, storage is at the heart of everything. Data, and I mean, I think we all agree that storage and data is at the heart of AI. I mean, you can't do any AI without it, and you couldn't, 10 years ago when it was traditional ML based. Where is DDN, and where do you see agentic AI from, because you have a lot of really, you've been in this space for quite a while, DDN has been, so it's kind of an interesting thing to see it evolve now to this agentic stage, which is slightly different, to put it mildly, than some of the previous.
Indeed, yeah, thank you. Great to be here, and as you've said, Rob, it's in a way the use case fell right in our lap when we started almost 30 years ago as a HPC play, and over the years we've had the benefit of increasing the capabilities of the storage software and making it reliable, robust, scalable. And when AI came along first, it was training and then inferencing and agentic AI. So increasingly, we're seeing a need where the traditional storage software needs to step up and be more higher performing and being able to maximize the expenses, the tremendous GPU expenditure, and being able to maximize the utilization of that. First it was training, and now in agentic AI, it's taken an interesting turn where, as Praveen and Kevin pointed out earlier, the temperature of the data is rising, and the way I think of it conceptually is a iceberg, where the tip of in the old days the tip of the iceberg used to be the hot data, everything else was cold. Now the whole thing is the data where you could extract at any point. You do RAG inferencing, you extract data at any point. So that's where agentic AI is, and that means you need to be able to actively manage the entire data set. So with that in mind, thanks to our partnership from the early days of the AI revolution, we had the opportunity to develop our software into Exa and more recently Infinia, which heavily takes advantage of the fact that there's a large data set of different protocols, different media types, different data sizes, right? And being able to bring them together in a single dashboard and make sure that you're able to serve the application at the speed at which you need to keep the GPUs busy. So with that, the task of the software has become even more complex. On one end, on the hardware infrastructure management end, you have to keep the CPUs and GPUs busy, and they're getting more and more powerful by the day. And then the SSDs, of course, right? They're getting larger, and PCIe Gen 5 has a high throughput. So being able to efficiently use the infrastructure on one end, and on the other end, you want to be able to serve the GPU workloads and the applications, particularly agentic AI, where if you have a query, to your point, Rob, you leverage the RAG capability, and being able to do so with high performance and low latency. So that's where it becomes a little more complex at scale with different data types. You have images, videos, and you have different protocols, right? S3, you have POSIX, file systems. So with all these protocols, with all these data types, and location, you could do it on the cloud or on-prem. So being able to wrap your hand around this complexity and this diversity, and being able to do what you need in real time, is the challenge that came in front of us. And if you look at a sample agentic AI or RAG pipeline, you'll see some of these elements that we talked about, and where you can see the storage software really make a difference is the ability to accelerate the GPU and make sure that you're running it at high utilization to ensure you get the best ROI, and the lowest latency. So we have the highest performing object store, the lowest latency object store today in the market, which is about 100 times faster than, or lower latency than, AWS. And so what that does is it allows you to do more lists. when you do a list command, you are able to see a lot more than what you would see if you had a higher latency software solution. So that is a direct, tangible example of how you can benefit from a high-performing storage platform. Then being able to seamlessly handle a multi-protocol scenario, and being able to accelerate your network, being able to do SQL querying in order to minimize data transition back and forth, so that can maximize your infrastructure utilization. So we thought through many of these and had the opportunity to develop it over time. And I'm happy to say we have a robust platform that customers have found extremely beneficial. And one such customer that adopted our solution runs a large GPU cluster, more than 100,000 GPUs. So the solution has been proven at scale, and we're glad we have the kind of partners we have here to make it all happen as an ecosystem. One of the examples where we ran a RAG pipeline in-house while developing our capability and fine-tuning our capability, I wanted to share a little story with you where, if you see the chart on the right side, we took a standard RAG application running on the cloud, right? AWS cloud in this case, and then we said, okay, how can you accelerate this further? Okay, let's go to GPU, right? That's the next step up. That's the bar you see in the middle, the gray graph. We move from a CPU to a GPU infrastructure, and then you see an acceleration, right? Enabled by the GPU. There's no tuning there, right? We're just moving from a CPU infrastructure to a GPU. And then when we replaced the AWS object store with Infinia object store, no other changes, we saw a tremendous speed up in meaning the improvement in latency, which results in the application speed up of 22x, right? So that shows you the power of designing and developing the right storage management and the data intelligence software required to meet the demanding applications such as agentic AI. So.
Yeah, no, I think that is really key. I mean, when you look at agentic AI and RAG and inference, a lot of it is around the unstructured data and how fast can you feed the GPUs, because a lot of these enterprises, when they go and buy the GPUs, those are pretty expensive assets. It's like a factory. You want to keep it busy, and you have to have fast storage. So, Vince, where do you see this going from an agentic AI storage perspective within the Supermicro portfolio here?
Yeah, great. Thank you, Rob. So we talk about a lot of capabilities required, especially we come into the play. First one, AI has been booming in the industry, actually changing everyone's life. And for example, the large language model, Gen AI, it's a milestone, and then it changed people's ways of living and working. And agentic AI here, we talk about the capabilities to really have goal-driven, and then it can take autonomous decisions. Okay, with that is we can foresee a lot of new exciting applications coming, and we just like all other speakers talk about the complexity. We heard a lot of the requirements. So agentic AI can be deployed, for example, large scale as a service in the cloud data center. It can be deployed in the on-prem facilities of enterprises. It can also be implemented in the far edge. So we just look at all these factors, and then the demand for performance, scale, and those for example, data transfer capabilities. The complexity is getting higher and higher. So that come to a play. Supermicro come into a play as an infrastructure provider. So you might have heard about our talking about the data center building block solutions. In the past few years, we have been working with technology partners and also heavily engaged in supporting our customers. So we have we have been offering the great system building blocks, but at the same time we work on the requirements and then we have actually invested and extended the capabilities into the data center level. So as you can see, to run a large scale like AI GPU data centers, these are critical building blocks like compute, storage, networking fabric, and then the critical power, facility capability, cooling capabilities. These are a lot of like challenges potentially for people who want to deploy. So with the Supermicro values bring on the table, we definitely can help customers really to have simplicity, but at the same time, time to deployment, time to online, and potentially it's like customers can save like more than 20% of overall cost. Okay, and this is like an example with the partners here with the AMD SanDisk DDN. It's a reference architecture at rack scale. We are looking at really something. Inference used to be like people think about comparing to training is a relatively lighter, but the agentic AI with the applications and capabilities, we are talking about potentially like a huge scale and then a large capacity. So an architecture here actually demonstrates like the partnership here with AMD's base GPU systems. Recently, like AMD introduced the MI350 Instinct GPU architecture. So we, Supermicro, work closely with AMD to bring that to the market, first to the market. And we talk about the need of getting the data to the GPUs. So we actually have the broader portfolio on the network switch, the latest like 800 gig switch with advanced capabilities in terms of orchestration, fabric management, and also like adaptive routing for the performance. Most important here, we are talking about the storage. It's a combination of the greatness from the partners. We were able to like provide the pre-validated, fully qualified and ready to ship solutions. So here is we can have a closer look at the solution, storage solutions we can offer to the customers. With the partnership with DDN, we were able to like deploy the large scale like storage systems for AI data center customers. And then particular for this one, you are looking at running DDN like Infinia Data Intelligence Platform on Supermicro AMD-based servers. We are looking at really on the rack scale. You are looking at like 60 petabyte capacity as a building block to scale. So we talk about like the growth of data and then the need of the performance. With the integrated solution, we are able to really provide the powerful performance and at the same time, really ease of use as a simplicity and running at very high efficiency in terms of cost and operation efforts. And also it's with the architecture, it's almost like have no limit to scale and support the growth of the customer demand. So for customers with different infrastructures, different requirements, we are here really to work with partners, and then we can design and architect, offer like the best solutions for our customers.
Yeah, I mean, I think that really speaks to what we were talking about at the beginning here, which is, hey, you know, you got to start somewhere. How do you start somewhere and then be able to grow into that solution over time? That's not going to pigeonhole you one way or the other, because agentic systems tend to be, lumpy is the way I kind of put it, because you have some of this, RAG here, but that inference may call out to an API that brings in data that then causes another inference to happen and bring things back. But that all has to come together, and from a stack perspective, let's jump into some questions here, because I got some things rattling around in my brain here that I want to know about. Like, Kevin, you kind of brought up the fact of AMD really pushing in on a full stack AI solution or portfolio. Kind of help us understand what does full stack mean to AMD?
So for the full stack, actually, when we look at the slides before, right? So it's not only about the CPU, GPUs. We had edge and the client. So that's the hardware piece, right? So everybody's talking about that. It's like a building block to support infrastructure. But the big thing is about the software stack, right? The RACOM, kind of glue everything together and let the engineers and developers and put together effort and to make this kind of like solutions better and better. And the other thing I think is pretty important, I think this panel gives the answer, is without work with the ecosystem partners, like system builders, and without work with our software, the vendors, and it can be happen. So this is a kind of like collaborations and efforts for the whole community to contribute to this, the new AI era. Yeah.
Yeah, I think that to me is really a key. It's the optionality, because not every AI workload is the same. Yeah. Balaji, one of the things that I look at is that you guys, like you said, you've been in this space, and before we called it AI and calling it ML and traditional AI and things of that nature, but really it's all the way through that stack, and where storage is really a critical piece to it. How do you really help ensure that that is not the bottleneck for customers? How do you really lean into the fact that you want to deliver the best end-to-end outcome, which may be more than just the storage aspect of it? So how does DDN go about that?
Right. Yeah, a great question. And the complexity increases with scale and with the application, right? So in the case of agentic AI, where let's say you have one tenant versus if you have 1,000 tenants, right, running concurrently, the complexity goes up, and that's where Infinia has a unique multi-tenancy architecture, where it's really granular. It's unique of its kind in the industry, where you have a granular multi-tenancy architecture that supports, you create a tenant and then you create subtenants, and then you can have SLAs and quality of service for each tenant and subtenant. So thinking through architecting it the right way for scale, and some of this comes directly from our ethos of in the HPC world, and translates and scales into AI and agentic AI. And it's scaled beautifully well, and it's architected really well. And that's just one example of how you can demonstrate this high performance and low latency, which are two fundamental capabilities, and linearly scale it over whether it's one tenant or 10,000 tenants.
Yeah, it would seem that just to build on that for a second, it would seem that for enterprises in particular, as they look at, hey, I may have an agent that's part of my reinsurance business, and that is, I have to cordon off, I have security and things from my mutual funds or something like that, because it can't cross lines. It would seem that these types of capabilities really, feed into agentic, especially when you have more than one agent running against a system or something of that nature. Absolutely.
That's key, and it's important on-prem. It's also important on the cloud. And if you're doing hybrid, you're needing to do both. The other thing is to be able to minimize data movement so that you can you don't have to do egress and data because that introduces latency, it introduces delay, performance bottlenecks. So Infinia has a special architecture that minimizes data movement, and not only that, due to extensive ability to tag, almost unlimited tagging, which is the first time in the industry, to be able to tag all the data so that you can fast find when you need to find it, and embedded SQL query added to that, right? And with extensive tagging, really allows you the capability to minimize data movement, and being able to tag and find and retrieve the data when you need it, and extremely helpful for agentic AI and RAG.
Yeah, especially where that's basically what vectorization is and everything. So I think that gets them there. I think again, Vince, from a perspective of agentic AI, it can be super powerful. What should be considered when people are looking to design not only for today but for the future? What are some things that they should think about?
Okay. We just like in our work with our customers, and then they are looking for, we emphasize the time to deployment. They are always like want to get into market or get into the service business as soon as possible. We know that the challenge we are supporting, but at the same time, we know like we need to set a spec to implement, but at the same time, just like looked at the agentic AI behaviors, is that it's more like a new way of accessing data. You are looking at like collect even more data. So when architecting the solution, you definitely need to think about like your upgrade path. So like our experience with customers, they deploy the systems easily like 20, 30 petabyte, but like immediately they realize is that, they ran out of space. So with the powerful like agentic AI use cases, we definitely can expect that. And then a great example here is that we are looking at like SanDisk, Praveen mentioned about their roadmap of growing the capacity per drive, and then we are looking at the density. So it's good. It's always good to like think about like the room for your business growth, and then at the same time, we have the technologies here with the Drive AMD roadmap, and DD and Infinia is the architecture. We emphasize the scalability. For Supermicro, in terms of infrastructure implementation, we have the capabilities not just on the system, but in the rack scale, in the data center scale. For example, like addressing the power, we have the capabilities really to help customers. At the same time, growth the performance and density, we can address and offer the best of power, cooling, and infrastructure solutions to deliver not just performance, but at the same time, super efficient solution.
Yeah, I think that's a key, and I'm going to key off of the efficiency because, Praveen, I mean, when we look at it, people are saying the AI race is going to be won because of power. And power in particular, these trillion parameter models that eat up tons of time on GPUs and really draw a lot in. But not only that, there's other things that draw a lot of power. And I think that, storage has been one of those, I wouldn't say guilty by association, but, again, over the years, as things have gotten bigger, things have gotten more efficient. But how do you see that? How does SanDisk see it from a perspective? How do you make AI more efficient?
Yeah, thanks. Great question, by the way. I think power is top of mind for everybody today, especially the data center architects, because GPUs are power hungry. They're almost 10x more power hungry than CPUs. And what that means is that if you're working with a certain budget, a large portion of that is being allocated to GPUs, which means you have less share of wallet on the storage side. That's point number one. Point number two is power rates are actually different across different geographies. And it's actually becoming the biggest constraint when you're designing new data centers or maintaining existing ones. In fact, I've read some statistics that it's more than 60% of a data center's ongoing OpEx. So power is the new metric that we need to incorporate when we are measuring storage performance. And that's why we are pushing things like IOPS per watt, throughput per watt. And the way we are enabling this is really by offering different power states. And so this is where we are innovating, and we can work with the ecosystem to really be mindful of, as the workload performance needs are shaping, you can actually dial up or dial down the power state to really extract less or more performance out of the drive. And you can do it in real time, and so you can actually modulate your power footprint on an ongoing basis. So SanDisk is very proud to be innovating, not just on the performance piece, and the capacity piece with the roadmap we showed that I didn't get a chance to talk to. But we are innovating not just on the performance and capacity density, but also in power and performance efficiency by offering different power states so that we can really start measuring storage per watt, IOPS, and throughput.
Yeah, I'm surprised you didn't go tokens per watt there, but that's the next step, right? Is hey, how efficient is my models versus power versus IOs and things of that nature. So we got time for one or two group questions here. I may throw in an extra one here just to see the reaction, because I love talking to you guys about this, and being a storage geek at heart, I look at this and go, the stuff that we used to build and grids and other stuff that was like state of the art back in the day, and we would distribute it, and then you had things like you had a lot of different ways of distributed networks and distributed processing and things of that nature. But now with your AI and what you see, there's again a concentration of bringing the AI to the data. There's gravity to the data still. What are you seeing from customers as you look at this across these customers that that really is something that they're saying, hey, I have to rethink my storage architecture, because what I built previously, it was good, and maybe it's good for those traditional apps, which may be part of an agent. There may be calls through APIs and stuff like that, or through database calls and things. But how are they really trying to think differently about it, and kind of what would be a recommendation to them about, hey, when you're starting to rethink your storage, here's what you need to think about from an AI agentic perspective?
So maybe I'll go first, but I think it's important to realize that AI is a forcing function in this re-architecture of the data center. And clearly we want to minimize data movement, as Balaji is talking about also. So there is some initiatives in the industry around how can we limit the data movement, but also more importantly, how do we speed up the IOs? And there is some initiatives in the industry of taking that IO administration away from a CPU core to a GPU core, because you can have a lot more GPU cores that can fire away those IOs a lot faster, because you have many, many more cores. And so there are some initiatives we are working on with some of the industry partners to really bring more data and then also bring these GPUs closer to the data so we can avoid some round trips. So it's an ongoing challenge, and we are working with the ecosystem to how best to solve these problems. But clearly, data movement, power, higher performance, I think these will continue to be top of mind as we re-architect this new data center.
Balaji?
Yeah, I think Praveen has a very good point, especially with the data movement and the power. Power has been a limiter, or soon becoming, if not already, a limiter, right? Based on which you decide how big your data center is going to be. But to your original question, Rob, the way people think about the infrastructure include, I'm assuming it's about the storage infrastructure we're talking about, right? There's the compute infrastructure, then the storage infrastructure. There's the storage hardware system, and then there's the storage software. Historically, if you went with the on-prem, then it was more or less bundled. So now we see it disaggregated, if you will, right? And there's a tremendous need for a one-stop shop storage solution, because customers don't want to shop for, there's one for object, one for file, one for block storage, right? So that's a legacy construct that's getting abstracted away to something that can run on a state-of-the-art hardware platform with the best servers, the best CPUs, the best SSDs, and being managed overall by a top-of-the-line software platform that accepts any and every data thrown by the GPU, and it carefully manages all the infrastructure underneath, right? So being able to maximize the GPU utilization at the top, and carefully, doing the delicate dance and maximizing the infrastructure underneath.
Yeah, that makes total sense. Seeing we brought up GPUs, Kevin, what do you see? What's one piece of advice you would suggest as people reinvigorate or reinvent their storage infrastructure?
Yeah, so I think we cover most of the aspect, right? So, but one thing I'm more thinking about is scalability, right? So, because data is growing really fast and into scalable. This is, related to the points that like software defined. If you can use some more standard, kind of a server or platform, but use the software to manage all the data. So that will be the trend. I think more and more customers are looking for this kind of more open kind of like architect and to support their storage growth. Yeah.
That makes total sense. I think, Vince, you guys see it all, right? You're the easy button for organizations when they're looking for this type of solution. Where do you see it? What's one piece of advice that you see and want to provide out for organizations that are sitting there going, okay, what do I need to do? What's the first step in getting ready for agentic AI as I build out my other AI tools that are going to be part of that agent?
Yeah, I was just like to share like the conversations with the customers. We traditionally think about like data centers isolated, but think about like just agentic AI. We talk about data coming from almost everywhere. So it's and also like data center maybe just like have a locality. So think about that like you have the GPU part and then you have the data set next to them, but when you grow, you have multiple parts. It actually brings a very interesting discussion, like especially in the industry, talking about introducing photonics, not just in the pod, and then what about data center interparts. So that's an idea to think about, considering like we talk about not just storage, especially like with Stadium, we emphasize like the data platform. You need to think about it's not just a dedicated storage, and then you probably need to broaden your view on potentially looking at multi-parts, and then how you manage your data across multiple sites. And then with that in mind, you will have a different architecture really to think about how you manage the data, and then with the right implementation, like the work with Infinia, DDA Infinia, get you the idea of not just accessing the data. We talk about like a streaming concept of the data. That will be potentially grow really beyond the data center or beyond the single part.
Yeah, I think all of that makes sense. I think this is a great place to leave it. I think those are great pieces of advice to the organizations about where they can really get started. So, hey, thank you for coming on board. This has been a great segment. I think, always great to see you guys.
Thank you.
Thank you. Enjoyed it.
And thank you for watching this episode of the Supermicro Open Storage Summit, really digging into storage for agentic AI solutions. Stay tuned for more.